A marquee text is a text animated to scroll. It can be used to show a long text inside a small container or to simply add a visual effect to it. There are many marquee styles. In this video we are going to create a couple of them using the tools WFS Studio provides us. Before we start, remember, there are many ways of achieving the same result. I'll add a text component here and set its size to be 33 by 190 pixels. These values are arbitrary. You can use any other, you just need to adjust the math. I'll show the current moon phase name on it using tags. I'll also add a rounded rectangle with the same dimensions. I'm using the rounded rectangle just for style. As I'll use the rectangle as a mask, I have to move it under the text. I'll also make sure they are aligned. Now let's make this text move. I want this text to fully move inside the red container in 1 minute, that is, 60 seconds. As the container has a width of 190 pixels, all I need to do is divide 190 by 60. It gives me 3.16 repeating pixels per second. I'll use the second with milliseconds for it to be smoother. Good, now it moves, but in the wrong direction. I'll add a negative sign to invert this. Now if I mask both components, only the part inside the rectangle will be displayed. But in this case, I want the text that is being cut to be displayed on the other side. For that, I can copy the same text component and add 190 pixels in the x-coordinate. 190 pixels, because this is the width of the container and the text component. 150, the current value, plus 190 is 340. Now I'll have two texts masked with the container that moves 190 degrees to the left. As only the part inside the container is visible, it will look like the part that is being cut on the left edge is being moved to the right edge. When the second reaches 0, it moves back to the original position, so the cycle repeats. Okay, but this expression by itself consumes processing, and I have two that use the same logic. A better practice, in this case, is to remove the tags from the components, then group them, and add the expression to the group, like this. See, same result, but this time only one expression is being used. I'll make this scroll faster. Instead of taking 60 seconds to do one full scroll, I'll change it to 30 seconds. 190 pixels, the width of both the text and the container, divided by 30, is 6.3 repeating. This tag here gives me values from 0 to 60. If I do this tag mod 30, it will give me only the left part of the division of the tag value by 30. Now it goes twice as fast. But I think it is still slow. Let's make it 4 times faster. 60 seconds, divided by 4, is 15. 190 pixels divided by 15 is 12.6 repeating. The same logic for the 30 seconds I can use with the 15, I just need to replace this 30 with 15. Now it looks a bit better. Let's add a border around this. For that I'll add another rectangle with the same dimensions as the mask. I'll place it over the marquee, and I'll align them to look like it is a container. Let's make it even better by adding a fading gradient to the edges of the components, so the text will look like it is fading away instead of being cut. For that I'll add a linear gradient to the rectangle I'm using as a border. As these components are used together, I'll group them just to keep things organized. A marquee will consume more battery than usual. Let's try to save some battery in case the watch battery is low. For that I'll add a conditional line for this group, so it will only exist in the watch face when the battery is over 20%. But when the battery is under 20%, nothing shows, and I don't want that. So, I'll create a copy of the text and the border outside this group. As they don't have the expression on them, they will be static and consume less battery. Again, as they are used together, I'll group them. But I don't want the same information repeated, I want it to show when the other is removed. So, I'll add a conditional for it to be displayed only when the battery is under 20%. I'll also remove the gradient and set the text to be centered to have a better look, and I'll align them so they will occupy the same space. Now when the battery is under 20%, the static text shows, and when it is equal to or greater than 20%, the marquee shows. But what if the text is longer? Let's test it out. I'll add the same components I used before, but this time I'll set a longer text. Now the text width is 455 pixels. I'll align them. See, the text will be cut out if I mask them. Let's make it scroll, but this time, only to show the part cut out. The width of the text is 455 pixels, the width of the container is 190. The width outside the container is 455 minus 190, which is 265 pixels. So, in order to show the part that is cut out, I need to animate the text 265 pixels to the left. As the text is long, I'll make it scroll faster. Let's make it scroll completely in 10 seconds. 265 pixels divided by 10 seconds gives us 26.5 pixels per second. The logic for the seconds we already know how to get using the mod operator. So, the expression will look like this. And don't forget the negative sign. Good, it works. Now let's mask it. Note that the text quickly resets its position when it reaches the end. I'll improve this. Let's make it scroll completely out of view. For example, this text component has a width of 455 pixels. If I want it to scroll out of view, I need to scroll 455 pixels to the left. 455 pixels in 10 seconds is 45.5 pixels per second. Cool, now we have a marquee with a long text, but it can be quite hard to see the beginning of the text as it scrolls fast when it resets. What if I make this component have a delay before it starts scrolling? As I kind of like the behavior for this one, I'll copy it instead of modifying its logic. I'll add a text here just to help me show you the logic. The logic of the seconds I showed you before makes the second go from 0 to 9, as you can see. I can also make it go from 0 to 19 by changing the 10 here by 20. I'll copy this component again just to help you visualize the next logic. If I add the relational operator less than and the number 10, it will return me 1 when the value is less than 10 and 0 when the value is equal to or greater than 10. Now the first 10 seconds I'll have the value 1, and the next 10 seconds the value 0. 1 is true and 0 is false. I can use these values in a conditional. For example, if true, return A, otherwise return B. I can combine this logic with the marquee moving logic. I'll show you. Let me copy the logic from the marquee first. Now, if the second is less than 10, I'll return 0, therefore, the position will not change. If the value is equal to or greater than 10, in the otherwise part, I'll return the logic for the marquee. Now let me copy this equation here and put it in the marquee. See, now the text stays in position during the first 10 seconds because of the 0 I returned, then it moves during the next 10 seconds because of the logic returned. When the movement is over, the cycle repeats, it returns to the same position and waits another 10 seconds. As I said in the beginning of the video, marquee can also be used to simply add a visual effect on a text. For example, let's make a text bounce back and forth. For that, I'll copy these two components to make things faster. The width of the container is 190 pixels, half of it is 95 pixels. I'll make the width of the text 95 pixels. I'll also add a shorter text in here, as this marquee is not to display cropped text. As I want the text component to reach the end of the container, I need to make it move the width of the container, minus its width. As its width is half of the container, the amount I need to move has the same length, that is, 95 pixels. 95 pixels in 10 seconds gives us 9.5 pixels per second. That is, 95 divided by 10. So, the expression would be like this. Now it goes till the end of the container, then restarts the position, but I want it to bounce back. If I apply the same logic from the delayed marquee, it will stay still for 10 seconds, then move during the other 10. If I replace this 0 by 95, which is the number of pixels this component is moving, it will stay in the ending position after it reaches there, and it will only return to the start when the second condition is used, which adds 9.5 pixels to its position per second, starting at 0. In other words, this expression here goes from 0 to 95. If, when I set this part to 95, it stays in the ending position for 10 seconds, I can make it move back during those 10 seconds by using the same logic I used to make it reach that position. That is this logic here, which, again, goes from 0 to 95 in 10 seconds. But I need to invert this time I want it to move from 95 to 0. For that I can subtract this logic from 95, like this. Now when this logic is 0, this whole part here will be 95 minus 0, that is 95. When this part here is 5, this whole part will be 95 minus 5, that is 90. And when this part here is 95, this whole part will be 95 minus 95, that is 0. Let's test it out. See, when it reaches the end, it goes back now. It bounces. We can also do these marquees with curved text. For example, let's reproduce the infinite marquee using curved text. I'll set it to have a size of 400 by 400. But once again, you can use any number, just adapt the math to the value you are using. I'll make it cover 90 degrees starting at 315. I'll also align it to the center of the canvas. To align it horizontally I can use this tool here. To align it vertically I'll need to do some calculation. The size of the canvas is 450 pixels, and the size of this curved text is 400. 450 minus 400 is 50. So, there are 50 pixels of extra space. As I want it to be centered, I need to divide 50 by 2, that gives us 25 pixels. That's the distance this component needs to be from the top of the canvas. Now, just like the linear marquee, I'll add a copy of this text. This time, as it will rotate, I need to add some angle to this extra text, instead of moving it to the right. It will rotate around the center of the canvas. So, the pivot needs to be at the center. If the canvas is 450 pixels in size, half of it is 225 pixels, which is already here. This curved text has a length of 90 degrees, so I need to rotate the second text the same amount. Now we need the mask. I could use a rectangle here, but I don't think it will look good. The best option would be an arc of 90 degrees. We can create an arc with a progress bar. As the arc has to be equal to the curved text, I'll just set the same properties here. Great, now let's make this progress bar thick enough to cover the text. I think 31 of thickness will do here. Now let's mask it. Both curved texts need to rotate the same amount, so once again, let's group them and add the expression to the group. The width of the text is 90 degrees, so we need to rotate 90 degrees in x seconds. Let's make it have a full revolution in 10 seconds. So that would be 90 degrees divided by 10 seconds, which give us 9 degrees per second. Before adding the equation, let's make the pivot point be at the center, that is, 225. Again, we are creating a marquee that will rotate around the center of the canvas. Now we can add the expression, this time to the angle input. Don't forget the minus sign. Cool, now we have a circular marquee. Let's add some fading like the other one. For that I'll copy this mask progress bar here to save time. The only thing I'll change here is the cap style in order to make sure it will cover all the area. Now all I have to do is add the gradient, then adjust it as I wish, like this, and done. In the description of this video, you will find the link to my GitHub page. In it you will find some extra content, like expressions, app IDs, and a list with all projects I have created in video, including this one. This is all for this video.